Hey everybody, so in this video I'm going to talk to you about motion with constant acceleration in physics. These kinematical equations are very useful, and you could only use them when you know that acceleration is constant throughout. You could apply these, most of the times you're using these in, if not all the times, you're using these in projectile motion problems. And so yeah, these are the four equations. It's very useful to write them down. I'm sure you're going to have them on a reference sheet for a test. But let's apply this to a sample problem right here. So we're given that the question is, a plane accelerates from rest, reaching a velocity of 80 meters per second in just 20 seconds. And so we're given that acceleration is constant, so we can apply one of these four equations. And all you need, so if you take a look, there's four different variables in each equation. We have Vx, V0x. This 0x means the initial, and that's the final. So you could write this as final and then initial. And then we have acceleration and time. So that's four different. And here we have another four different. We have the displacement, the final x minus the initial x. We have time, that's 2, as v0x, that's 3, and vx, that's 4. And same for these other two. So all you need is 3 variables to use, and then you solve for the fourth one, because there's 4. All you need is 3. You need 3 knowns, and then the one left unknown is what you're solving for, and that's how you get your equation, or your answer. So let's just write down whatever we know here. So it says that the plane accelerates from rest. That means we know the initial velocity, v sub 0x, is equal to 0, because it started at rest. And then it reaches a final velocity of 80 meters per second. I'm going to use a marker. So we have v initial velocity is 0, and then we have the final velocity, we could write it as v sub x. They have given it to us, which is 80 meters per second, and then we know time is 20 seconds. And so those are 3 knowns, and the unknown that we want is acceleration. So if we look, we have to choose one of these 4 equations that has these 3 knowns. We could take a look at this one. We have Vx, V0x, and time, and we're looking for Ax. And so this is the equation that we're going to use for this specific problem. Okay, so write it down. Vx is equal to V0x plus Axt. Okay, so we could plug in what we know. So Vx is 80 meters per second is equal to V sub x 0. We need to write that. And then we have Ax times time times 20 seconds. And so we want to isolate the acceleration, so we divide on both sides. And so we get 80 divided by 20, which is 4, and the units is meters per second, or meters per second squared, and that is the standard unit for acceleration. And that is the answer. The acceleration is 4 meters per second squared. And now part B, they ask how far did it travel. Again, the first thing you want to do is write down 3 knowns. So we know the initial velocity, we know the final velocity, and we now know acceleration, even though we could use time. But let's just use acceleration. It doesn't really matter. So we know these, and then the unknown that we want to find is x minus x0. How far did it travel? It's displacement. So let's say this is the runway and the plane is right here. So it starts from here at rest, and then let's say we want to know how far did it travel in those 20 seconds. So at this point it was going 80 meters per second, and we want to know this displacement starting from 0. So x sub 0 is 0, obviously, because it didn't move, and we want to find x, its displacement. So we could use one of these 4 equations where it has v0x, vx, ax and x minus x0. So it's going to be this equation. So I'm running out of space. So we could use the fourth one. Vx squared is equal to v0x squared plus 2ax, and then x minus times x minus x0, like that. So the Vx squared we know, which was 80 meters per second. So we're going to square that, 80 squared. The initial velocity was 0, and then we found the Ax, which was 4. So that's plus 8 times x minus x0, which this is what we're going to find. So we could divide on both sides, 8. So using the calculator, 80 squared, 6,400 divided by 8. And so x minus x0, the displacement is, according to the calculator, 800 meters. And so, yeah, that's a sample problem of kinematical physics using one of these kinematical equations. There are 4. Always remember that you need to find 3 knowns, and then the last unknown is what you're looking for. So you just need 3 variables, and that's enough to use one of these equations to solve for the 4th unknown. And that's it.